This is about section 6.1. I cover the number 1 to number 7 in the review problem set. Before I start, I want to talk about the use of calculator. You have to be careful with the mode of the calculator. Currently, in my calculator, it is degree mode. If you need to find the answer with radian mode, then you will change the mode to radian by DRG button. So currently I switch it to the radian mode. So I said DEG is degree mode. And RAD is radian mode. And DRG button is the function key which changes the mode. Problem number 1 to problem number 5 is about changing the changing degree to radian and radian to degree. What you have to keep in mind is pi equals 180 degree. When we switch radian to degree and degree to radian, you use this relation. There are other fundamental angles which you will just know how the corresponding degree and radians are. For example, when you hear 2 pi, you should be able to figure out the corresponding degree, 360 degree. When you hear 360 degree, you should be able to say that that is 2 pi. And pi over 2 is 90 degree, and pi over 3 is 60 degree, and pi over 4 is 45 degree. Of course, that is according to the ratio. When we compare pi and 180 degree. So pi over 2 is half of pi, and pi over 90 degree is 1 over 2 times 180 degree. Problem number 1 is changing the degree, 41 degree to radian. So radian is unknown, therefore I will put that as x. And x is unknown, I will compare that with the ratio with pi, and corresponding degree to 41 degree is x. A corresponding degree for x is 41. So I would write 180 degree because that corresponds to pi. So I would multiply by pi on both sides, then x equals 41 times pi over 180. Let's use calculator. 41 times pi divided by 180. So that's approximately 0.716 radian. because 6 is following 5. 5. Be careful about the instruction. In this question, you are asked to write the up to 3 decimal points. Number 2 is we have to convert 2 pi over 3 to degree. Let's follow the straightforward method. Degree is x, so I would write x, and we compare the ratio between 180, and on the right side, the corresponding radian is 2 pi over 3. We are comparing that with pi, so pi corresponds to 180. So I multiply by 180 on both sides to get the degree. So x equals what? This is the numerator, 2 pi over 3. And this one is in the denominator. So I would write down 1 over pi times 180 over 1. These two are canceling each other, and this one will cancel and simplify it to 120 degree. So what did I use? A over B can be written as A times 1 over B. This part is the reciprocal of denominator. This is the first method, but if you already know the common senses correspondence, then you know that pi over 3 corresponds to 60 degree. Therefore, 2 pi over 3, which is 2 times pi over 3, is 2 times 60. Therefore, that is 120 degree. So you can go either way, but I think the second one is better if the denominator is 3. Number 3 is 5 pi over 4. I would use the second method. You can try the first method also. So 5 pi over 4 equals 5 times pi over 4. Therefore, that is 5 times 45 degree. And if you use calculator, then that will give you 225 degree. So let's do it. 5 times 45, 225. Number 4 is 5 pi over 6. Again, we will use the common sense. So 5 pi over 6 can be written as 5 times pi over 6. Therefore, that is 5 times this one corresponds to 30 degree. So 30 degree, that is 150 degree. Let's do number 5. Number 5 is negative 3 pi over 2. We will use the common sense again. Negative 3 times pi over 2 will make negative 3 pi over 2. Therefore, that is negative 3 times pi over 2 is 90 degree. Therefore, that is negative 270 degree. Number 6 and number 7 are about coterminal angles. When that is given as radian, algebraically, that is theta plus 2 pi n. What is coterminal angles? Coterminal angles are the angles which share the terminal side of the angle. For example, this is theta, and we consider this angle. This is theta plus 2 pi, and those are coterminal angles because terminal side of the angles are the same. When we convert that to degree, the differences among the coterminal angles will become the integer multiple of 360 degrees. So n is integer. Let's do number 6. Number 6 is 130 degree and 490 degree are given, and you have to determine whether those are coterminal angle or not. What we know is when those are coterminal angles, the differences among those angles will be 360 degree times n, when that is given as degree. So what we will think about is differences of two angles, then that is 360 degree. This is an integer multiple of 360. So the answer is yes, those are coterminal angles. Let's do number 7. Number 7 is 17 pi over 6 is given. This time, this is a radian angle. And we have to find the angle between 0 and 2 pi, which is coterminal angle. So we have to figure out what is 2 pi when the denominator is 6. That is 12 pi over 6, because this one is 2 pi over 1, and we multiply by 6 on the numerator and denominator. So we realize that 17 pi over 6 is greater than 12 pi over 6. Therefore, we think about the angle we obtain by subtracting 2 pi. So that is 5 pi over 6. So what we thought about is the angle we obtain, smaller angle we obtain by subtracting 2 pi. And we know that this one is obviously less than 2 pi and greater than 0. And so that satisfies the condition in the problem.